Hi there, welcome back to this channel. In this quick video, I'm going to be showing you how to find the oxidation number of an atom within a molecule. So of course you know that oxidation number is the hypothetical charge of an atom within a molecule or a compound, alright? And we said that it is differentiated from valency because when we say valency, we don't really expect you or we don't mandate you to give the charge of that atom. So, but if we say oxidation number, you have to tell the charge. So, for example, if I asked you for the oxidation number of oxygen, you would say -2 and not just 2. But if I asked you for the valency, you could tell me 2 and that suffices. If I say what's the oxidation number of aluminum, you could tell me you will tell me +3 and not just 3, you have to include the charge. Is that okay? So that's what separates the valency from oxidation number. But of course, they quite refer to the same number. Is that okay? Only that in oxidation number, mandatorily, we include the charge because that's the definition of oxidation number. It is the hypothetical charge that an atom has within a molecule. The hypothetical charge, I repeat, that an atom has within a molecule or a compound. All right, let's go on to solving this. This one says to find the oxidation number of iron in iron chloride. Now, this is how we go about it. Now, this is how we go about it. Number one says to find the oxidation of iron within FeCl3. Now, the first thing you must take a look at is this. Is this compound in the ground state or is it in the excited state? Now, a compound will be in its excited state or now if it's a compound, a compound is always in the ground state. So if it's a radical will be in the excited state. Is that okay? A radical will be in the excited state. So is in the ground state. If you see that the total charge, there is no charge here. So if there's no charge here, it means the total charge here is 0. So the total oxidation number that, oxidation number in this compound is going to be 0 because it's in the ground state. Ground state of the oxidation number is 0. Excited state oxidation number it corresponds with the charge that you have here. So for example, if I gave you a molecule like this, SO4 2 minus. Now, when you see this, you know that the charge, the sum of oxidation numbers here is going to be -2. You see PO4 3 minus, the sum of oxidation number here is going to be what? -3. Is that okay? The sum of oxidation number here is going to be equal to the charge that you find on top. Well, here there is no charge, so we know that it's in a ground state, and because of the ground state, we know because of it's in the ground state, we know that it is going to be what have a total charge or a total oxidation number of 0. So total oxidation number here in our compound FeCl3 adds up to 0. So we are looking for that of iron. So that of iron will be represented by X. Just follow me. That of iron will be represented by X. So X plus, now what is the oxidation number of chlorine that we have here? Now, chlorine has a particular oxidation number of -1. Chlorine has an oxidation number of -1. Now, so what I will do is I'm going to link a video in the description where I talked about how to find the oxidation number. It's very, very easy. So chlorine has an oxidation number of -1, and if you don't know, it's just 287. So it's going to receive 1, that will be -1 because it's add more electrons, so that will be -1. So, and 3 is given here. So we say that -1 times this 3 that is given. So the sum of all these oxidation numbers should give us 0. As we said, is in the ground state. So we have that X we're looking for plus 3 times -1 is -3, then is equal to 0. So we have X minus 3 is equal to 0, and X therefore will be equal to what? 3. So the oxidation number of iron here is what? 3. So the IUPAC name of this compound will be what? Iron 3 chloride. Because of course there will be iron 2 chloride. Iron is a transition metal, so it's going to have more than one oxidation state. Now, number two question. Number two question says to find that of Mn, manganese, in KMnO4. Okay, we use the same principle. Is there a charge here? No. So it means that the total oxidation number will be what? 0. Good. Now we are looking for Mn. So we have potassium oxidation number. Potassium has an oxidation number of +1. +1 because it is the octet rule electronic configuration will be 2881. So it's going to give out that one, and because it's giving out that one, it's going to have one electron less. So it's going to be +1. Is that okay? Then plus manganese is what we're looking for, and no number is given here, so we just write our X. Plus that of oxygen is always -2. Take note of that. It's always -2. So we have -2 times what number is given here? 4. This subscript must multiply it. Is that okay? So the total oxidation will be what? 0. So we have +1 plus X -2 times 4 is going to give us what? -8 is equal to 0. So here we have these two will leave to that side so that X alone will be left here is equal to, here 8 becomes positive, right? Because it was negative here, it becomes negative here. Positive here becomes negative here, so -1. So we have X is equal to 8 minus 1 is what? 7. And that's how to get about it. You see, that's very, very simple, right? All right. The next one says, number 3, says K2Cr2O7, okay? We are told to find that of chromium. Now look at what we'll do. Now we know that potassium from where we did, it was +1, right? So it's going to be +1. Now we're given 2 to multiply by 2. Do you understand? So that is 2 times 1, all right? Then these subscripts, those numbers that are given as subscripts always multiply the oxidation number. Take note of that. The numbers given as subscripts always multiply their oxidation numbers. So we are looking for that of chromium, so that is +X. Now a subscript is also given here, that is 2, right? So you multiply again by 2, and then you have plus. Now that of oxygen we said is always what? -2. So we have -2 by 7. The total oxidation state is also what? 0, because there is no charge there. So we have 0. Does that make sense to you? So we have +1 times 2, that will be +2, then plus 2 times X, 2X, -2 times 7, -14 equals 0. I mean, plus will multiply that minus, I will still have the minus. Is that okay? The same way we collect like 10. This guy goes there, this guy goes to meet it. All right? What do we have? We're going to have 2X alone left in this side, on the left hand side. We have 14, -14 will become 14 there, and +2 become -2 there. So that we have 2X is equal to 14 minus 2 is what? 12. Then we divide both sides by 2, and we're going to have what? 6. So X will be equal to what? 6. Does that make sense? All right, let's continue further. Now let's go to number 4. Just stick with me because we're soon going to get to some that are not tricky, but you might find confusing. All right. Number 4 says N2, that is sodium. By the way, this is potassium tetraoxomanganate. What did we calculate for manganate the other time? We calculated 7, right? So this we called what? Potassium tetraoxomanganate 7. Is that okay? Then for this guy, K2Cr2O7 is going to what? Potassium again. Hepta 7. Hepta represents 7. Is that okay? Heptaoxochromate. Do you see where I'm going? I said potassium tetraoxomanganate. This is the way we name those ones that have radicals. This is a radical MnO4 2 minus. This guy is also a radical MnO4 minus rather. This guy is also a radical Cr2O7 2 minus. So it is potassium heptaoxochromate 6. Is that okay? Then this one is sodium thiosulfate. Alright, we have N2S2O Na2 rather S2O3. We are told to find that of sulfur, right? We're looking for sulfur. Now we know that potassium and sodium is going to have the same oxidation as potassium because they are both in group 1. Group 1 corresponds with oxidation number 1. All right, so +1 times 2 again. 2 is given, right? Now, I've explained the dynamics of how this is happening. in forming compounds. So I'll look in the description so I can see that. And plus, we are looking for that of solve for x. We are given 2, so multiply by 2. Does that make sense? Then plus 3, oxidation number of oxygen is always minus 2. Then times 3 that is given is equal to 0. Does that make sense? Then we'll continue and say this times this is what? Plus 2 plus 2 times x, 2x. Now plus minus 2 times 3 is what? Minus 6 is equal to 0. So we have now 2x will be left here. Then minus 6 will go here because this will give us minus, right? Okay, so we have plus 2 also go there. So we have 6 positive, 2 negative. Is that okay? So we have 2x is equal to this minus this is what? 4. Then divide both sides by 2. So that we have what? 2x will be equal to what? 2. And that is our answer. Now let's go to the next. The next one says, number 5 says NH4 plus. Now this is ammonium ion. Now you have to listen to this one carefully because it is quite different from the ones we've been doing. Now look at this one. There is a charge here. So it means that the total sum of oxidation number is going to be what? Plus 1. If it was 2 plus, you saw here. And by the way, we write it this way because you could have expected that we wrote plus 2 if it was more than 1. That is, for example, we want to write that of magnesium, right? Magnesium Mg2 plus. Now, the reason why we chose scientists or chemists chose this convention, number before the charge, is because if you write plus 2, one of the reasons, not just the reasons, okay? One of the reasons is that if I wrote this, some students may write something like this. And this thing could mean Mg plus 2. So you could mistake it for something else. So it's best to write something like Mg 2 plus. However this looks, you always know that this is not squared. Is that okay? And that is 2 plus, it means that is the charge. It looks more easier to recognize as an ion here than this. This might mean, this could, mean mathematics or something. Is that okay? So this conversion is easier, where we write the number before the charge. Okay, let's go on. So we said the total charge is going to be plus 1. Now let's see that. We are looking for that of nitrogen, right? So nitrogen, we have X plus. Now what's the oxidation number of hydrogen? Hydrogen is group 1. And that's the only reason why it fits in group 1, because the oxidation number is mostly plus 1. So we have plus 1 times what we are given here, times what? 4. So we go on to saying that X, so everything is equal to plus 1. X plus 4 times 1 is 4, is equal to 1. This guy goes there and we have what? X is going to be equal to 1 minus 4. And therefore, X will be equal to what? Minus 3. So the oxidation of nitrogen is there is what? Minus 3. All right. Let's solve further. Let's go to number 5. All right. Number 5 says, we go solve number 5. Let's go to number 6. Number 6 says, to find the oxidation of phosphorus in PO4 3 minus. Okay, now there's what you do. You know that the total oxidation number is going to be what? Minus 3. Are you following? Then we're looking for that of phosphorus, so we say X plus 4 times that of oxygen, which is always minus 2. That is times 4. And we have X plus this times this is what? Minus 8 is equal to minus 3. Does that make sense? So we have X minus 8 is equal to minus 3. 8 comes here when we collect like terms. Then we have X is equal to what? Minus 3 that was here before. Then plus 8 because it was negative here. Once it comes here, it becomes positive. Then we have X is equal to minus 3 plus 8. Basically, it's minus 3. That's what? 5. And that's the oxidation number of phosphorus there. All right. So, and that's why the radical is named tetraoxophosphate 5. All right. Let's go to number 7. Number 7 says CONH363 plus. Now, this, if you have seen my video on acid, bases, and salts, this guy is we call it a complex salt. It's a complex salt. All right. So now let's solve for oxidation of cobalt. Now, cobalt is spelled C-A-C-O-B-A-L-T. So, cobalt. All right, let's find the oxidation of cobalt, and then we'll have that of, now, the total oxidation right here is going to be what? Plus 3, all right. So, we have X, which is what we're looking for, plus, notice there's no subscript outside here. This 6 works for only these guys. Is that okay? So since you have 6 outside here, I'm going to put 6 outside into bracket. That of nitrogen is what? Minus 3. You remember for what we solved here, nitrogen is minus 3. So we have minus 3, then plus, now that of hydrogen here is 1. So, but 3 is given here. We open another bracket. So let's call this, let's make this a square bracket. Then we have 3 into times, this 3 times 1. Then we close square bracket. And then we have our 6. So the sum of all of this must give us what? Plus 3. Does that make sense? I'll reiterate. Cobalt is what we're looking for. The oxidation of cobalt. So we have X plus, now 6 is outside of bracket here. For both, we multiply the oxidation of these guys. So when it multiplies it, so it stays outside, then into bracket, that of nitrogen is minus 3. The oxidation of nitrogen is minus 3 plus 3 into bracket, hydrogen is 1. So 3 times 1. Then everything must give us what? Plus 3. So we have X plus, now, let's still leave 6 in bracket. Let's work inside the bracket. Minus 3 plus 3 times 1 is 3 equal to plus 3. Does that make sense? Now, this takes care of this. And what will that give us? 0. So 6 times 0 is 0. So X is the only one left here is equal to 3. And that is the answer. That is the answer. All right, let's go to number 8. Number 8 says CuSO4, copper sulfate, copper tetrasulfate 6. It says to find the oxidation of copper here in this place. So we have X plus sulfur is now. The name of this compound is copper tetraoxo, copper 2 tetrasulfate 6. Now I know that, but if you are told to find this, it means you have to know the oxidation of sulfur. Now, the oxidation of sulfur in SO4 is always 6. It's always what? 6. So we have plus 6 plus 4 into bracket. That of oxygen is minus 2 equals 0 because it's a compound, ground state. Remember? X plus 6 minus 8 is equal to 0. So X is equal to 8 minus 6, and that is what? 2. So copper has a number of 2 in that molecule. Then the next one, number 9, we have SnCl4. SnCl4. Now, I'm going to be solving all of these 10 questions, but if you need me to give you test questions based on all of this, I have an archive of about 20 more questions on oxidation numbers. Some are simple and as simple as this, others are as complex as this. So you can reach me on this WhatsApp number 090 plus 234 9021416307. All right. So let's go on. We said we have to find the oxidation number of tin inside tin chloride. So we have what? X plus what? Because that's what we're looking for. Plus 4 into bracket. Or 4 times the oxidation number of chlorine. Remember, we said was 1, minus 1 actually. So equal to 0. That's ground state. There's no charge here. Remember? All right. So we have X plus 4 times 1 minus 4 equals 0. X minus 4 is equal to what? 0. This guy goes here and we have X equal to what? 4. Does that make sense? All right. Let's go on. Now, number 10, which is the last but not least, we have to find the oxidation of molybdenum in NH4 to MoO4. All right. Molybdenum is MO. All right. We're told to find the oxidation of molybdenum. So here, You know that we already have 2 here, so bring that 2. I mean, these two guys are inside the bracket, and then they have a molecule. They are, they appear twice. That's the meaning. So 2 into brackets. Now, the oxidation of nitrogen, remember we said was what? -3. So the -3 plus 4. Hydrogen is 4, so that'll be 4 times 1. I mean, oxidation of hydrogen is 1, but we're giving 4 here, that'll be 4 times 1. So let's make this a square bracket. Then plus molybdenum, what we're looking for, X, plus oxygen again, 4 into brackets, or 4 times -2, which is the fact that we're given 4, and this natural oxidation bar is -2. The total charge here will be what? No charge, so it's 0. Ground state, remember? Good. So we have 2 into bracket -3, 4 times 1 plus 4, then plus X plus into bracket 4 times -2 -8 equals 0. So here we'll have 2 into bracket -3 plus 1, 1 plus X plus -8 is equal to 0. Do you get that? So we have 2 times 1, 2 plus X minus 8 is equal to 0. So from here, this will come here and this one will follow it. So X will be equal to what? 8 minus 2. And X becomes what? 6. And that is the oxidation of molybdenum in that compound. All right, this will be the end for the end of this video. I'm going to start a series after this jam series. I'm going to start a series called Accords. Accords means anybody can understand this. So we're going to be doing it on chemistry and physics. Accords chemistry and accords physics. So, alright, so do well to stay tuned and subscribe to the channel so that you don't miss out on any of these series. In that series, I feel the need to simplify some concepts that people think are actually hard to understand. So make sure you look up to that series. God bless you. Share the video with your friends as well.